Hi guys, welcome back to my YouTube channel. In today's video, I will be talking about RAG based document Q&A project. So in this project, I will be teaching you the concept behind RAG using LangChain, and after that we will just have a walkthrough of the code, how the RAG pipeline is implemented in our Google Colab. So without getting any delay, let's get started. So first, I want to tell you about RAG concept. So the concept we are going to talk is about RAG. RAG stands for Retrieval Augmented Generation. This is the abbreviation for RAG, and this is used in LLMs to keep the model up to date when the LLMs are having a knowledge cutoff. So what is the drawback of using an LLM is we have our LLMs, right? LLMs have some knowledge cutoff. That means uh, if if we ask some latest question that is out of the context or out of the date question, knowledge cutoff, if we ask the LLM about the question that it does not get trained on, it will give some answer, but the answer will not be accurate, and it will be uh, generating with some hallucinations, and the answer will not be accurate. So for this problem, the concept we are using here is RAG. So in order to deal with this problem, we are using RAG as a framework for LLM to deal with this kind of problem. So how is this RAG framework is built upon? Let's see the architecture of how it is working. First, there is a knowledge base. Like there is a knowledge base first. I will write it here. Knowledge base is nothing but we have our PDF files, right? PDF files and doc files and other kind of text files. So these files are stored in our knowledge base. These files which are used are we want to update our LLM to its latest knowledge. So we are grouping these PDF files, doc files and text files in our folder. So these files are converted into embeddings, right? Embeddings are nothing but numerical vectors. Numerical vectors that has some value. This text is converted into some numerical vectors that has some numerical value that represent the value that represent the context of the text. So these are called embeddings. So this kind of embeddings are generated by transformer models. Like for example, there is BET model developed by Google. So this is one kind of embedding model based on a transformer architecture developed by Google. So we store these embeddings in a vector database. Right? So there are in the market there are many vector databases such as ChromaDB, then Pinecone, then FAISS. There are many vector databases used for storing embeddings in this kind of vector. So vectors are stored in the vector databases. What is the benefit of using these vector database instead of relational databases is relational databases stores in the format of a text format. So right, it stores in a tabular format, but whereas here in vector databases it will be storing in terms of vectors. Suppose a vector is kind of a numerical array containing like this numerical values. So this is a example for vector. Multiple kind of vectors are stored in this vector database. So this is an example of a vector. So what we are going to do in this RAG pipeline is a text for suppose I love cats. There is a text sentence like this. So this is converted into embedding like numerical embedding to store in this vector database. Right? All the text files we have in our knowledge base are converted into vectors using these embedding models like BERT developed by Google. For example, Google, all these kind of embeddings are stored in the vector database such as ChromaDB, Pinecone and FAISS. So right, you are clear up to this, right? Then in this pipeline we are going to include LLM. LLMs are nothing but large language models that give response based on a prompt. We give a query to LLM, then it gives us the response. This is basic concept of an LLM. So large language models are trained on a huge amount of data. They are trained on huge amount of data. Using neural networks, these LLMs are trained. When we give a text query, this query is also converted into embedding, such as a numerical vector. When we ask a question to this LLM, this question is converted into embedding and given it to the LLM, and the response is generated. This is the normal working of an concept of LLM. We are discussing about the concept here is RAG. So we will attach these two pipelines. I will take another color, just a minute. So here we are filtering some vectors. That means if some user is asking about a question about a PDF file, he want to ask some question about the PDF file. like there is a book, a PDF file. He asks some question about this book. So in this process, this pipeline will filter the vectors that are relevant to the question. Relevant vectors are filtered and given as input to this LLM. So LLM will take the two inputs here. One is query and the other one is the filtered vectors that are contextual relationship with the query. These two inputs will given to LLM and the response is generated more accurately. The response will be generated. So next, in this process, how we are going to measure which text are similar. So how we are going to measure the text relevance with each other? So there is a concept, there is a metric called cosine similarity. This cosine similarity will tell us that whether the two vectors are similar, dissimilar or irrelevant. So if that cosine similarity value is 1, then they are similar, then the vectors are similar to each other. If it is 0, then they are dissimilar or irrelevant to each other. And if it is -1, it is opposite direction. Two vectors are in opposite direction. This is also called as a dissimilar case. In this way, we will measure the two text sentences relevancy. So this is about cosine similarity, and there is a formula for it to measure the cosine similarity. If there are suppose two vectors in our database such as x1 comma y1 and other vector as x2 comma y2, there are two vectors, then the formula for cosine similarity is, if we consider this as a vector and this is as b vector, then a dot b by magnitude of a magnitude of b. This is the dot product. Numerical numbers are, this is dot product, and this is the simple magnitude multiplication. Right? You know the dot product formula. It will be for suppose here a and b vectors are there, right? How we are going to do the dot product for these two vectors will be x1 into x2 plus y1 into y2. This is dot product, and the below magnitudes are calculated in this way: square root of x1 square plus y1 square into square root of x2 square plus y2 square. This is the cosine similarity. I think you have understood what is the RAG concept here. I will tell you more practically in code walkthrough. So guys, this is the end of the video. I will be showing you the code for document based Q&A RAG project in the next video. As the video is already lengthy, about 15 minutes, I will be cutting it into the part 2. So I'll see you in the next one. Thank you.